Okay, we're gonna try this again, and this time we're gonna do it right. 8.1 and 8.2. I'm gonna do a test that I made. Hopefully that will help some of y'all out. 8.1 is all about finding the average value of a function. So just adding up a whole bunch of y values and dividing by the number of x values, basically. 8.2 is all about connecting position, velocity, and acceleration through some type of integration in some way, shape, or form. So I got 8 questions. Let's just start with number one. All right, number one, the average value of f of x equals 1 over x squared from -4 to -2 is something over something. So literally just average value. Add up all the y values by taking the integral from -4 to -2 and then dividing by, in this case, 2, but I'll show you how I got that. So I'll just start up here so that way I have room to work. So the average value is going to be equal to 1 over b minus a, so -2 minus -4, times the integral from -4 to -2 of, yes, it's 1 over x squared, but I'm trying to integrate it. So I'm going to write it like x to the -2 dx. So that's my setup. So I just got to integrate this and then plug in some numbers. So -2 plus 4 is what? 2. So 1 over 2 times, now the integral of x to the -2. I'm going to use reverse power rule. So I'm going to add 1 to the exponent and then divide by that new exponent. And then I'm going to evaluate that from -4, to -2. Okay, reverse power rule. Add 1 to the exponent and divide by that new exponent. Taking a number to the power of -1 is kind of weird. So I'm going to write it like this. I'm going to say 1 over 2 times. Now, there's a property that says I can move this x to the -1 on bottom if I make that exponent positive. So it'll be 1 over -1x to the first. So that's just going to really turn into this. From -4 to -2. Okay, move the exponent to the bottom, so it's just x to the +1, and then that negative sign is still there. I low-key want to factor that negative sign out. I think I'm going to do that. So I'm going to finish down here. I'm going to factor out that -1/2 just so it doesn't, mess me up. And then it's 1 over x evaluated from the top bound minus the bottom bound. So my negative sign is already taken care of. So I'm going to go 1 over -2 minus 1 over -4. F of b minus f of a. And then that should give me my answer. I'm just going to make common denominators. So I got my -1/2 out front. Let's see. If I double the numerator and denominator in my first fraction, I would get what? Negative, or I'll just write it like this: 2 over -4, and then minus 1 over -4. So now I have common denominators. I should write this as like -2 over 4 plus 1 over 4. But anyways, it'll be -1 over 2 parentheses. So if I move the negative sign up to the numerator, that'll be -2 plus 1. -2 plus 1, which is what? -1 over 4. -1 over 2 times -1 over 4, that's just 1 over 8 is what I'm getting. Somebody double check me. I'm going to let people know that I'm streaming real quick, and then I'll do number 2. So I got 1 over 8. I got 1 over 8. Let me text this link real quick. For number 2, a particle travels along the x-axis, so it gives you the velocity, and it wants the total distance traveled. All right, total distance traveled should not be that bad. Remember that for total distance traveled, we want to consider the absolute value, or all like the positive areas in my graph. So first I want to check at any point does my graph get to like underneath the x-axis, because that'll be negative area or like negative distance traveled. But since it's asking for total distance traveled, I want to only consider, I want my area to only get bigger and never smaller, if that makes sense. So first what we're gonna do is from velocity we can figure out position. From velocity we can figure out position. So my position, I'll call it x of t. That is going to be the integral of v of t, which will be the integral from 0 to 3 of 6t minus t squared dt. But before I do that, I'm going to see, like I said, at any point, does my graph get below the x-axis? That's what I'm trying to see. Because then I'll have to like consider that negative area separately. So what are my factors? I can factor out a t. That'll give me 6 minus t. Okay. So then I'm basically trying to see what are my roots. My roots are t equals 0 and then t equals 6. 6 minus 6 will give me 0. And then since my leading coefficient is negative, hopefully y'all see that I can write this like negative t squared plus 6t. And so since my leading coefficient is negative, I know that I'm going to be concave down. My graph is going to be concave down and my roots are going to be here and here, 0 and 6. And so the only way that that can happen is if I'm like this. But the interval that I'm interested in is only from 0 to 3, which you can see that all of that area is positive. So I'm good. I don't have to worry about like negative area at all. If I did, I would just have to, separate that integral up, only consider the negative area, and then make that area positive. So this literally is all I have to do to find this question. So I'm going to go, the integral of 6t would be what? 6t squared over 2. So 3t squared minus t cubed over 3. And then I'm taking this from 0 to 3. So all I got to do is plug in 3 minus plug in 0. So when I plug in a 3, let's see, 3 squared is what? 9. 9 times 3, I believe, is 27. Minus 3 cubed over 3. 3 cubed is what? 27. 27 over 3, I believe, is 9. So 27 minus 9, I believe, will give me 18. If my math is correct. So I'm saying 18 on this one. Okay, number 2. I said number 2. I just did number 2. Number 3, a particle. Particle motion, this is probably 8.2. It travels in a straight line with a constant acceleration of 5 meters per second. Okay. I gotta figure out how to get this YouTube link sent so that I can share it with people. What did it give me? It gave me acceleration. If the velocity is 2 at time t equals 1, how far does the particle travel during the time interval when its velocity goes from 2 meters per second to 7 meters per second? Okay, so how do I do this one? Ooh, it works. And I have one person watching. Let's go. All right, let me send this to the group chat real quick. Hopefully it's not too late. Wait, why is it called this? This thing is titled improperly. Hold up real quick. I don't even know how to change this title. I need to learn how to work technology, because I don't even know why it's called this. Oh, I forgot to edit it. That's why. What do I call this? Calc stream 8.1 and 8.2. Okay, now we can appropriately title this stream. Hopefully it updates by itself. All right, so back to the math. We have a particle motion. It gives us acceleration. If I'm trying to find how far something traveled, I got to first find the velocity. All right, let me resend this stream real quick. Delete, send again. What? Why is it doing that? Hold up, y'all. Something went wrong. It won't even let me delete. Bro, technology is so glitchy. Okay, if it gives me A of t, how do I get V of t? Let's go. All right, so it tells me that my acceleration is 5. Okay, cool, bet. Now can I find my velocity? Can I find V of t? I should be able to find that by integrating 5, which hopefully y'all can do in y'all's head is just 5t, but you got to remember the plus c. Now, how do we figure out what c is? Well, they're going to give us some like condition that we can use. All right, let me try to send this again. Hold on. Last time. Whatever. I don't know why it won't get the right title. Anyways, so it gives us the velocity and it tells us that the velocity is 2 whenever time is 1. So I'm going to replace v of t with 2 and then I'm going to replace t with 1. And then that's going to allow me to solve for c. So if I subtract 5 from both sides, 2 minus 5 gives me -3 equals c. So since I know that my c value is -3, I can really write my v of t function. At first, it was just 5t plus c, but now that I know c, I can say that my velocity is 5t minus 3. Okay, so I have my velocity function. I will even go as far as to highlight it so that it stands out. So, but remember, I'm trying to find how far the particle traveled. So I still got to integrate this once more to get my position. However, the time interval for my position function, we have to find those time intervals. It says during the time where my velocity goes from 2 meters per second to 7 meters per second. And it's hard, but not really, because I gave you one of the time intervals. Earlier I said that when the velocity is 2, the time is 1. So that's my first bound. Now I got to figure out what is my time whenever my velocity is 7. So 7 is my velocity, which is equal to 5t minus 3. So I just solve for time. If I add 3 to both sides, I'll get 10 equals 5t. And then I will find out that my other time interval is 2. I mean, my t value is 2. So I'm trying to figure out how far the particle travels from, 1 second to 2 seconds. So this one was a little bit harder because you had to find those time intervals. So my answer is going to be whatever the integral from, what were my time values from 1 to 2 of my velocity function, which I said was 5t minus 3 dt. So that right there is what's going to give me my answer. And if I integrate that, that would be 5t squared over 2 minus 3t from 1 to 2. Okay, boom. So now I just plug in 2 minus plug in 1. All right, let's try this. So if t was 2, that'll be 2 squared, which is 4. 4 times 5 is 20 over 2, which is 10. I'm doing a little bit of mental math. Minus 3 times 2, which is 6. And then I'm going to go minus. All right, now when t is 1, this will just become 1 squared times 5, so 5 over 2, minus 3 times 1 is 3, but I'm going to go 6 over 2 for common denominator's sake. All right, so this is going to be 4 minus, what does this become? 5 minus 6, which is negative 1 over 2. So technically 4 plus 1/2, or 4.5. And I should label my units. This would be meters. 4.5 meters. Okay. I think the hard part is just setting it up, because again, you gotta integrate twice. Once to get your velocity, and then once to get your position. But you have to, first of all, you got to find your C value, and then you got to find both of your bounds. Actually, no, I take that back. You really only got to find one of your bounds, because I low-key gave you your first bound. So yeah, 4.5 is my answer for that one. Okay, number 4, conceptual. Bradley, if you're watching this, hello. She's piloting a plane across the Pacific Ocean. The altitude is given by A of t, where A is in feet and t is in minutes. Which of the following expressions gives her average altitude? If I give you a function that represents altitude, then those altitude values are like y values. So they're literally asking you what's the average y value of A of t from 10 to 20 minutes. So this is just a literal direct application of average value of a function. So it's going to be this one. From 10 to 20 minutes is a span of 10. So I'm dividing by 10, and I'm taking the integral of my altitude function from 10 to 20. All right, so that one should have took like 45 seconds. All right, number 5, another particle motion question. This one shouldn't be that bad. A particle moves along a straight line with the acceleration given by A of t equals 4t. We kind of already did one like this a little bit. So it gives you that the velocity is -2 whenever time is 0. And then it gives you that my position is 0 whenever time is 3. And then it just asks me to determine S of 6. All right, so I got to figure out a S of t function. But before I do that, I got to figure out a V of t function. But I can't do that until I integrate my A of t function. So it sounds, I mean, I guess it's kind of a lot of steps, but whatever. We got to find V of t first. So I'm going to integrate A of t, which is the integral of 4t, which according to reverse power rule, that's 4t squared over 2, and the 4 over 2 will make 2. So boom. And remember, you can always check by taking the derivative. What's the derivative of 2t squared? That's just 4t. Or I should say 2t squared plus c. The derivative is still 4t. So I have my velocity function, kinda. It tells us that when t is 0, my velocity is -2. So I'm going to say my velocity equals 2t squared plus c. All right. I can use this to find my c value, which hopefully y'all can see would be -2. So I'm going to say c equals -2. So now that I have my c value, I can say that my velocity function v of t equals 2t squared minus 2. I'll highlight it so it stands out. All I'm doing is replacing c with -2. So that's my velocity function right there. Okay, from my velocity function, I got to integrate that to get my position function. So my position function, I'll call it S of t, is going to be the integral of v of t, which is just going to be 2t cubed over 3. So it'll end up looking like that. A quick check, if I take the derivative, I will get 2t squared. And then I'm going to say minus 2t. Don't forget the plus c. Okay. Now I'm going to use my condition that S of 3 equals 0. I'm going to use that to find my new value of c. I should have did this at first. The first c that I found, I should have called this c sub v. C sub v for my velocity c value. This here, what I'm about to find is, I'm going to call this C sub S, my position C value. All right, we do want to make that little distinction. Okay, that's an S, not a 5. All right, so they tell us that my position is 0 whenever T is 3. So I'm going to go 2/3 3 cubed minus 2 times 3 plus C sub S. All right, now I just got to solve for C sub S again. Let's see. 3 cubed is 27. 27 over 3 is 9. 9 times 2 is 18. That's for my first term. I did 27 over 3, which is 9, and then divide or times it by 2. Minus 6 equals, I'm sorry, not equals, plus C sub S. All right, so 18 minus 6 is going to give me what? 12. So 0 equals 12 plus negative 12. So my C sub S value should give me negative 12. 12 minus 12 does equal 0. Okay, so now that I have my C sub S, I can go ahead and say that S of T really equals 2/3 T cubed minus 2T minus 12. I'm going to highlight that one for you. So I had found my velocity function, and then I basically repeated the process to get my position function. Okay, and then they want S of 6. So just replace T with 6, and then we should have our answer. So that would be, I'll just do it down here. S of 6 equals 2/3 times 6 cubed. I don't know what that is. Minus, I'm going to say minus 12. Minus 12. All right, 6 times 6 is 36. 36 times 6, I'm going to do that off to the side. 6 times 3 is 18. 18, 19, 20, 21. So 216. I'm going to go 216 over 3, and then I'm going to double it. Assuming 3 goes into 216. 3 goes into 21, what? 3, 6, 9, 12, 15, 18, 21, 7 times. That's 0. Bring down to 6. 3 goes into 6 twice. So 72 times that 2, though, that's going to be 144. Minus 12, minus 12. So that's going to be 144 minus 10, 134. Minus 2, 132. So 120? 120 what? It doesn't really tell us. Whatever our position is measured in. 120 is my final answer for number 5. Do I have any comments? Live chat. Oh, Nathan, what's up? Out of all people, how did I know you were going to be the one to watch? Thank you for tuning in. I'm going to reply W Nathan. Okay, so that was number 5. Now I'm about to do number what? 6? Okay, I'm going to erase. The average value of 2x plus 1 on the interval from 3 to 5. This one should be easy. I will admit that these problems are a lot of steps. I'm not even going to lie. These problems are a lot of steps. And because there's a lot of steps, there's a lot of places you can go wrong. I will admit that. Okay, number 6. Average value of a function on an interval. I'm just going to work down here. So that is just a literal direct application of average value of a function. So from I'm going to actually go ahead and go 1 over 5 minus 3 times the integral of 2x plus 1. This one is super slight. So 5 minus 3 is what? 2. So 1 over 2 times the integral of 2x plus 1. That'll be x2 times x squared over 2, which will just be x squared plus x from 3 to 5. Easy. Okay, I'm going to keep my 1/2 factored out. And then I'm going to go 5 squared plus 5. So that's 25 plus 5, which is 30, minus 3 squared plus 3. So 3 squared is 9. 9 plus 3 is what? 12? What's 30 minus 12? 18. So 18 times 1/2, 9. 7 is a solid question, one of my favorites. Yes, I like 7. I like 7 because it's not that bad. It's a little bit of trig, which could be an annoyance. 30 minus 12, yeah, that's 18. 18 over 2 is 9. For number 6, I got 9. All right, number 7. Nathan, I'm glad we share sentiments on this problem. I like it. Okay, so a particle travels in a straight line. I give you velocity. I don't even give you acceleration. We skip straight to velocity. What is the distance traveled from time t equals 0 to the time where the particle first stops? This one, when you read it, it sounds crazy, but just think about it. What happens when a particle stops? The velocity is 0. So we just got to find out what time is it when velocity is 0. That'll give us our bounds for our position function, or to find our position function. So the total distance traveled, our answer is going to equal the integral from time t equals 0 to some unknown time. We don't know what time that is, so I'm going to just put t right there, of 3 sine of 2x. The integral of our velocity will give us position, but with bounds will give us a distance traveled. Try teaching this with a velocity versus time graph. Oh, that'd be interesting. That'd be interesting. So I don't know, because like you can't use a calculator, so I can try to sketch it, because hopefully we know like kind of what a sine function looks like. It has something to this effect, right? More or less. And if this thing is a velocity, we see we start where the velocity is 0. We have some velocity, and then boom. So, you know, from dot to dot is what our bounds is. We're just trying to figure out what that t value is. And we can figure that t value out by realizing that velocity is 0 if the particle is stopping. And our velocity function is 3 sine of 2x. And so I'm just like, what x value, or actually, no, this is the one where it was a typo. I forgot. This one was a typo. It was supposed to be v of t equals 3 sine of 2t, not 2x, but still, same idea. Hopefully that didn't confuse people. I guess I can kind of see how it could. Hopefully it didn't. But we still got to solve for t. We have to solve for t. So I'm trying to think like what value of t would make this whole thing equal to 0. Well, first I divided by 3 on both sides. So I just got 0 equals sine of 2t. And I'm trying to think like sine of what will give me 0? Well, I know sine of 0 will give me 0, but like we already have that our lower limit has t equals 0. So that's actually like your starting time. We're trying to find the time where the particle first stops. So when else does sine of something equal 0? I'm trying to think. Sine of pi equals 0. So I need this thing right here. I need that stuff in parentheses to be equal to pi, because sine of pi would give me 0. So I need that 2t to be equal to pi, because if that were the case, then this would be a true statement. Sine of pi surely equals 0. Well, If 2t is equal to pi, I can just divide by 2 on both sides and get that t equals pi over 2. That's the first time that my particle stops, is pi over 2. So I can erase my t from my upper bound and replace it with a pi over 2. And then I just treat this like unit 6. It is u sub though, so hopefully y'all caught that. I'm going to let u equal 2t. So therefore du would equal the derivative of 2t, which is just 2 dt. And then shortcut, long cut, I don't know the way you like to do it, but first of all, this 3 that you see, that's a coefficient, so I'm going to pull that out. So it's 3 times the integral from 0 to pi over 2 of sine of u. Now, if I were to write du, then that would cover a 2 and the dt. I don't want that 2 there, so I'm going to divide it by 2 here. That's the shortcut way. That's the shortcut way. So now what I'm really integrating is sine of u, which is negative cosine of u from what? 0 to pi over 2? Okay. The derivative of negative cosine is sine. Camera's blocking the work. Oh, shoot. Let me fix that. Thank you, Nitin. I don't know where to move it. I'm still kind of new at this. Okay. Nitin, let me know how I'm doing. Am I in the way or no? Okay, I think I'm good. Actually, you know what? I'm going to move it to the right. There's nothing going on over there. Hold on. Let me put it like this. How does that look? Dang, I'm looking like such a noob. I'm good? Okay, bet. All right, now, the derivative of negative cosine is sine. So I think I'm good. Now, I'm going to go 3 over 2 times, I'm going to plug in pi over 2. So negative cosine of pi over 2. Now, I'm going to say minus negative cosine of 0. So I'm just do it like this. Minus negative is like a plus. So I'm really looking like this. Go all the way to the right. Otherwise it looks a little whack. Okay, hold on. I see what you mean. Okay. All right. So, what is cosine of pi over 2? That's 1. So, negative 1 plus the cosine of 0. Whoa. Backtrack. I think I just messed up. Cosine of pi over 2, that's 0. Cosine of pi over 2 is 0. I almost messed up on camera. Plus the cosine of 0, which is 1. So my final answer I'm getting is 3 over 2 or 1.5. Nitin, let me know if I messed up. Cosine of pi over 2, I'm pretty sure that's 0. Cosine of 0 should be 1. 3 over 2 times 1 is just 1.5. All right, I'm ready for the last one. And then I'm about to go to bed. Oh, it's conceptual. Nice. Okay, for the first 7 seconds, a particle travels along the x-axis. It gives you the velocity function. It gives you a position when time t is 0, which expression gives a total distance traveled from 0 seconds to 5 seconds. I made a mistake integrating. Dang it, bro. What mistake did I make? U sub. All right, let me check my work. Let's see. So we're integrating 3 sine of 2t. U is 2t, du is 2dt. Wait, no, never mind. Okay, good. Nathan, you can't be doing that to me, bro. You had me thinking I went out bad on camera. Okay. I'm good? Okay. Bet. Okay, whew. You have my heart beating fast. All right. So it gives you a position. The question says, which expression gives the total distance traveled from 0 seconds to 5 seconds? So they're not asking for the final position. They're only asking how much ground not even how much ground did I cover, how far literally did I travel? So I want an absolute value. So from that alone, I know it's either the second option or the last or next to last. And then this one can't be it because that -2 is like adding a position. And I only want distance traveled. So I'm going here. The last one is not it because that's kind of like an average value because of the 1/5 out front. So I'm going what? A, B, C, D, E for that one. Okay. Hopefully that helped. Rewind it, pause it, take screenshots if you need to. If you're watching this on the playback and have any questions, let me know. But that's my time, ladies and gentlemen. I'm going to save this PDF and I guess I'll send it to you if you need me to. But all right, I'm going to probably do this tomorrow. This was fun. Hopefully we can have more people. Nathan,